All right, let's dive right in. We need to talk about a hidden traffic jam that's gumming up the works of our green energy future. It's this massive bottleneck costing billions. But here's the thing, it's almost completely invisible.
Think about it. We're getting really, really good at generating clean power. But what good is all that energy if we can't actually get it to where it needs to go? That's the huge question we're going to tackle today.
So to make sense of all this, let's use a simple idea. Picture the entire power grid as one giant highway system. You've got power plants as the on-ramps, and our homes and cities are, the destinations. It's a really simple way to visualize what's actually happening behind the scenes.
Okay, so if the grid is a highway, then right now we are stuck in a massive system-wide traffic jam. And it's happening for a reason that you probably wouldn't expect. Here's the problem. The best spots for wind and solar farms, windy plains and sunny deserts, are often miles and miles away from the big cities that need all that power. So when they try to send all that energy down the highway, the system just gets overwhelmed. And grid operators have to do this thing called curtailment, which basically means they're forced to shut off the turbines and panels. All that clean energy just gets wasted because the highway's full.
But here's the wild part. The highway isn't actually full, not even close. We've been intentionally keeping entire lanes completely empty. And to understand why, we've got to look at the old school way we've always managed our energy highway.
It's all because of this safety rule called Preventive N-1 security. The whole idea is to run the grid with so much extra room that if any single power line fails, no other line will ever get overloaded. It's kind of like keeping the shoulder of the highway completely clear at all times, just in case there's an accident. It's super safe, sure, but as we're about to see, it is incredibly inefficient. So look at this. The old preventative way, on the left, meant we were only using a tiny fraction of our grid's real capacity. But a new, smarter, corrective strategy on the right could let us use the entire highway. Just making that one change unlocks this massive potential we've just been letting sit.
So let's put them side by side. The old preventive way? Well, it wastes capacity and it really struggles with renewables. But this new corrective approach, it reacts intelligently after a failure, which lets us use the whole network and finally unleash the full power of wind and solar. But wait, how can you possibly react that fast without causing a huge blackout?
Well, this is where the hero of our story comes in. There's this amazing technology that makes this whole smarter corrective strategy possible, and it's called a network booster.
A network booster is basically a high-tech emergency crew for the grid. It's usually a really big battery system that just sits on standby, waiting. If a power line goes down, these boosters can instantly inject power or pull it out to keep the whole system perfectly balanced. And they do it all in just a few minutes. So here's how it all plays out in real time. A line fails. For just a few moments, the other lines are allowed to handle a temporary, managed overload. But before that overload can ever become a real problem, bam, the network boosters kick in. They absorb the shock and rebalance the whole system. The result? No blackouts and no more wasted highway lane. Okay, this all sounds really smart, right? But what's the actual real-world impact? Let's talk about the payoff. A recent study modeled this exact scenario for the German power grid, and the results are just staggering. So if Germany's power system went all in on this corrective strategy, the potential annual savings would be 2.4 billion euros. That's every single year. And you can see it right here. With the old inefficient strategy, the total system cost every year is about 42.5 billion euros. By investing in these network boosters and switching to the new strategy, that cost drops all the way to 40.1 billion. That's your $2.4 billion in savings right there in black and white. And get this, those savings don't just come from being more efficient. They come from unlocking a much smarter way to build out our entire green energy system. We can finally build huge wind farms where it's windiest and solar farms where it's sunniest, because we know our energy highway can actually handle all that traffic. For Germany, this solves a huge classic problem. The study found the best plan was to put network boosters up in the north to soak up all that excess wind power, and then put other boosters down in the industrial south to supply power instantly if it's needed. What you get is a perfectly balanced system that moves clean power from where it's abundant to where it's in demand. Simple. So, let's bring this all together. What's the big picture here? Well, we're really talking about a fundamental shift in how we even think about our energy infrastructure. You know, this quote from the study pretty much says it all. Freeing up the grid doesn't just make it run better, it makes the entire system cheaper and more effective by letting us put our renewables in the places where they'll work the best.
So, the single most important takeaway is this: building a green future isn't just about building more hardware, it's about upgrading the software, the intelligence of our grid. These network boosters are like the brain that makes the whole system finally work smarter, not just harder.
And that really leaves us with a final question to chew on. Maybe the next great leap forward in clean energy won't be a new type of solar panel, but a breakthrough in how we move it around. It's not just about what you make, it's about how intelligently you can get it there. Thanks for tuning in.